Welcome to our deep dive into one of the most advanced pieces of technology humanity has ever created, the James Webb Space Telescope. You know, folks, we humans, we've been staring up at the cosmos for millennia, trying to unravel its mysteries, and over time, our tools for the job have gotten better. But the James Webb? This is a game changer. Let's explore its origins, functions, and the incredible discoveries it promises to deliver. So, what exactly are we talking about here? The James Webb Space Telescope, or JWST for short, is not just an incremental improvement over its predecessors like Hubble. Oh no, this is a whole new beast. Imagine a telescope so powerful it can detect the faintest light from the earliest stars and galaxies, born just after the Big Bang. We're talking about looking back over 13 billion years into the past, and it's all thanks to its incredible design. This thing is massive, with a primary mirror over 21 feet across, made up of 18 hexagonal segments that unfold and adjust in space. It's like origami, but for cosmic exploration. This design, along with its advanced instruments, allows it to gather light in infrared wavelengths, which is crucial for peering through cosmic dust and seeing the universe's most distant and ancient objects. Now you might be wondering, who is this James Webb character anyway? Well, unlike many telescopes named after famous astronomers, the JWST is named after a different kind of visionary. James E. Webb was the head honcho of NASA during the Apollo program, you know, the one that put humans on the moon. He wasn't a scientist himself, but he understood the importance of pushing boundaries and investing in ambitious projects. Under his leadership, NASA went from strength to strength, laying the groundwork for decades of space exploration. So, you see, naming the telescope after him is a fitting tribute to his legacy of bold leadership and scientific ambition. Now let's get into the nitty-gritty of how this thing actually works. The James Webb Space Telescope is designed to observe the universe in infrared light, which is basically heat radiation. Why infrared, you ask? Well, for starters, visible light from the early universe gets stretched out as it travels across vast cosmic distances, shifting into the infrared part of the spectrum. It's like the universe is playing a cosmic game of redshift. But that's not all. Infrared light can also penetrate clouds of gas and dust that obscure our view in visible light, revealing hidden stars, galaxies, and even the processes of star and planet formation. To capture this faint infrared light, the JWST has to be incredibly cold, otherwise its own heat would blind it. That's why it's parked 1,000,000 miles away from Earth, at a special spot called the Second Lagrange Point, or L2, where it can enjoy a constant, unobstructed view of the cosmos. Chapter 4. Unlocking the Universe's Secrets. This telescope isn't just a pretty face, you know. It's got a big to-do list packed with scientific goals that'll keep astronomers busy for decades. First and foremost, the JWST is on a mission to study the first stars and galaxies that formed after the Big Bang. We're talking about the universe's baby pictures, folks. By observing these early objects, we can learn about the conditions in the early universe and how galaxies like our own Milky Way came to be. But that's not all. The JWST will also study the atmospheres of exoplanets, planets orbiting other stars looking for signs of life. Imagine that, finding evidence of alien life. And let's not forget about studying objects closer to home, like planets, moons, and asteroids in our own solar system, revealing their secrets in unprecedented detail. Chapter 5. A Christmas Launch to Remember. Now, launching a telescope of this complexity and importance is no walk in the park. After years of delays and nail-biting anticipation, the James Webb Space Telescope finally blasted off on December 25, 2021, atop an Ariane 5 rocket from French Guiana. Talk about a Christmas present to the scientific community. The launch itself was flawless, a testament to the hard work and dedication of the engineers and scientists involved. But the real nail-biter came after. The JWST had to execute a series of incredibly precise maneuvers during its month-long journey to its final destination at L2. It was like a cosmic ballet, with hundreds of moving parts that had to work perfectly, and thankfully it did. Chapter 6. Seeing Beyond the Visible. So, how far can this telescopic time machine actually see? Well, hold on to your hats, folks, because the JWST can observe objects so faint and distant that they're over 13 billion light-years away. That means the light we're seeing from them started its journey towards us just a few 100 million years after the Big Bang. To put that in perspective, the Hubble Space Telescope, as amazing as it is, can only see objects up to about 13.4 billion light-years away. So the JWST is giving us a glimpse into a period of the universe's history that's never been seen before. And it's not just about distance. The JWST's infrared vision allows it to see through the cosmic fog of gas and dust that obscures our view in visible light, revealing hidden details of distant galaxies and star-forming regions. Chapter 7. A Limited Time to Explore. Now, as much as we'd love for the James Webb Space Telescope to be our cosmic companion forever, the reality is a bit more bittersweet. You see, the JWST has a limited lifespan, estimated to be around 10 years. This is mainly due to the finite supply of fuel it needs to maintain its orbit and orientation. But don't despair. 10 years might not sound like much on a cosmic scale, but it's enough time for the JWST to revolutionize our understanding of the universe. And who knows, with any luck and a little ingenuity, we might even find a way to extend its mission, squeezing out every last drop of scientific discovery from this remarkable observatory. Chapter 8. A Million Miles from Home. So where exactly is this marvel of engineering floating around in the vastness of space? The James Webb Space Telescope is parked 1,000,000 miles away from Earth, at a special spot called the Second Lagrange Point, or L2. Now you might be thinking, why so far? Well, there are a few reasons for this cosmic parking spot. First, L2 is a point of gravitational stability, where the gravitational forces of the Earth and Sun balance out, allowing the JWST to maintain a stable orbit with minimal fuel consumption. Second, being so far from Earth helps to shield the telescope from unwanted heat and light interference, which is crucial for its sensitive infrared instruments. It's like finding a quiet corner in a noisy room, but on a cosmic scale. Chapter 9. A Symphony of Technology. Now let's talk about what makes the James Webb Space Telescope such a technological marvel. First off, there's the massive primary mirror, over 21 feet across, made up of 18 hexagonal segments that unfold and adjust in space. It's like a giant gold-plated honeycomb, designed to capture as much faint light as possible. Then there's the sun shield, the size of a tennis court, which protects the telescope from the heat and light of the sun, keeping its instruments at a frigid minus 370 degrees Fahrenheit. And let's not forget about the advanced scientific instruments, including cameras, spectrographs, and coronagraphs, all working in perfect harmony to capture stunning images and unravel the secrets of the cosmos. Chapter 10. Cosmic Postcards from the Edge. And now, for the moment you've all been waiting for, let's feast our eyes on some of the breathtaking images captured by the James Webb Space Telescope. From the iconic cosmic cliffs of the Carina Nebula, revealing starbirth in unprecedented detail, to the deepest and sharpest infrared image of the distant universe ever taken, showcasing galaxies that existed just a few 100 million years after the Big Bang, each image is a testament to the telescope's incredible power and the boundless beauty of our universe. These images are not just pretty pictures, folks. They're windows into the past, present, and future of our cosmos, providing us with clues about how galaxies form, stars evolve, and planets are born. Each pixel tells a story, and it's up to us to decipher their cosmic whispers. Outro: a new era of discovery. Thank you for joining us on this journey through the cosmos with the James Webb Space Telescope. It's a testament to human ingenuity, a shining example of what we can achieve when we dare to dream big and push the boundaries of science and technology. The discoveries made by the JWST will undoubtedly rewrite textbooks, inspire future generations of scientists, and deepen our understanding of our place in the grand tapestry of the cosmos. Stay tuned for more updates and discoveries as we continue to explore the universe.